Greetings to Madam Siwa and Madam Nosha. Today, my team and I will be presenting our analysis of teaching and assessment issues within the number and measurement topic of primary mathematics, which is under the MTES 3273 and MTES 3243 Task 1. It's time to meet our team. Our team member is Kristin Lai Jun Hui, me, Jia En, and Kang Jia Hui. To begin, we have identified two primary issues. First is teaching issues that many students suffer from a weak foundation in place value during their early primary years. This isn't just about knowing numbers, it's about understanding the internal structure of our base 10 system. This leads directly to our assessment issues, a misconception of decimal place value, which that students compare digits as whole number instead of understanding the decimal place value. So according to our first research article, place value knowledge is built on two core principles: the position of a digit and its associated power of 10. This issue we found it that many pupils focus on the digit itself rather than its position. For example, a student might see the number of 26 and perceive it simply as 2 and a 6 rather than understanding that the 2 is actually represents of the 2 group of 10, like 2 times 10 power of 1. For another theory, which is supported by the CPRM 2019 regional report, looking at the table, we see that 14% of students are at band 2 or below. At this level, students are limited to counting small collections of objects or simple single-digit addition. The lack of the conceptual transparency needed to understand how 10 ones transition it into 110. The takeaway here is that if a children cannot draw conceptual understand connections between the different representations of quantities in primary school, they are at a high risk for mathematics learning disabilities as they progress through their elementary school or even like university. Now, let's look at how these early gaps evolve into decimal misconceptions. Research shows students often apply the whole number rules to decimals. This leads to the longer is larger fallacy where a student thinks that 0.125 is bigger than 0.3 because it has more digits, or the shorter is larger rule, thinking that 0.3 is bigger than 0.496 because tens are bigger than thousands. Like that, so that we analyze this through three lenses based on the TIMSS 2023 and Everyday Knowledge reports. Conceptually, students act as task experts, following memorized procedures like adding zeros without understanding the actual capacity of the number. There is a lack of variation in visual models that students struggle to visualize that a longer decimal string doesn't mean a larger volume. Real life use, like we found that relying too heavily on money, like such as the two decimal place, makes students ignore the digits beyond the hundreds place. Essentially, the research clarifies that errors are a direct result of instructions. When we teach decimals using the whole number logic, we inadvertently interfere with the student's ability to grasp the true decimal notation.
Good morning, everyone. I'm Christine. Today, I will be presenting on health teaching issue based on Team PISA and CPLA, focusing on weak place value understanding in primary mathematics. First, place value is a foundational concept in mathematics. It helps students understand the value of digit, compare number, estimate quantities, and reason mathematically. However, international and regional assessments show that many primary students still struggle with this concept. Let us start with teams. From the teaching perspective, teams emphasize understanding number concepts such as place value, number comparison, and reasoning. However, in classroom practice, teaching often focus on memorizing a digit and writing number rather than understanding the value of each digit. As a result, many students struggle to reason about large number and their magnitude. This leads to weak performance in reasoning-based questions, especially when students need to explain their answer. Therefore, teams highlighted the need for problem-solving tasks that involve comparing number, estimating value, and explaining number signs. Next, PISA focused on applying mathematical knowledge in real-life situations. However, classroom tasks are usually routine exercise and not connected to real-world tasks. Because of this, students cannot interpret number meaningfully in daily situations, such as money, data, or quantities. These weak foundation in place value affect their ability to solve contextual problems. Hence, PISA emphasizes problem solving using real-life situations to strengthen number understanding. Lastly, CPLN measure basic numeracy and number understanding at the primary level. In many classrooms, lessons focus more on completing the syllabus rather than developing deep understanding. As a result, some students may reach the minimum achievement level but still lack strong number sense. Conceptual gap in place value remain among many learners. CPLN therefore stress the importance of reasoning activities such as using number line, grouping, and estimation. In conclusion, findings from Team PISA and CPLN consistently show that weak place value understanding is a major teaching issue in primary mathematics.
Hello everyone, my name is Kang Jia Hui. Today I will discuss an important assessment issue in mathematics, specifically the misconception of decimal place value, based on findings from TEAMS, PISA, and CPRM and other articles. Decimal place value is a core numeracy concept, yet international assessments show that many students misunderstand the size of meaning of decimal even when they can perform calculations. First, teams uses a curriculum-based assessment aligned with school mathematics. Most tasks are structured and close-ended, such as multiple choice or direct decimal comparison question. While these items assess procedure accuracy, they do not sufficiently probe students' conceptual understanding. As a result, misconceptions such as believing 1.2 is greater than 1.15 often remain undetected, as students rely on digit comparison rather than place value reasoning. Next, PISA adopt a literacy-based approach, focusing on real-life context like money and percentage. Although PISA aims to assess reasoning, many students perform poorly with when decimal must be interpreted in context. These indicate weak place value, understanding, and difficulty applying decimal knowledge to every situation. Finally, CPRM focuses on foundational numeracy through simple decimal magnitude and comparison tasks. However, the assessment provides limited diagnostic information, allowing early misconception about number size and place value to persist. In conclusion, across Team PISA and CPRM, the key assessment issue is that decimal place value misconceptions are not sufficiently identified. To address this, assessment should include more diagnostic and reasoning-based tasks that reveal how students think, not just whether their answers are correct. Thank you. Good morning, everyone. My name is Kang Jia Hui. Today, I will discuss these issues of measurement. For teaching issue in measurement is lack of spatial variation. Students' difficulty in reading values between scale marking suggests limited exposure to hands-on measurement activities involving various container shape, partial fillings, and non-standard measurement situation. For assessment issue is poor understanding of millimeters and liters. Assessment issues of millimeters and liters. The low performance in items requiring of interpretation of millimeter indicates confusion about unit size and quantity, including difficulties in identifying more or less misconception, such as treating liters and millimeters as interchangeable. And then for this section, explain the teaching and assessment issues in measurement based on CPLM and TIMSS finding. CPLM 2019 show that for a band 5 items involving reading liquid volume in a measuring judge, 80% of students in band 4 and below could not answer correctly. This suggests students struggle to interpret continuous quantities, especially when the liquid level is between the scale markings. This reflects a teaching issues of lack of spatial variation, where students have limited hands-on experiences using different container shape and partial fillings. As a result, students rely on visual height rather than the true volume. In assessment, students show a poor understanding of millimeters and liters. They confuse unit and cannot accurate judge which quantity is more or less. The sharp performance drop from band 4 to band 5 indicate that measurement tasks require higher spatial reasoning, a weakness also reported in TIMSS 2023. These findings show the need of more varied teaching approach and real-life measurement assessment issue. And then I will discuss the teaching and assessment issue in measurement, specifically capacity, based on PISA finding and research article. First, in terms of the concept understanding, teaching often focus too much on formulas such as 1 liter equals to 1000 millimeters without helping students truly understand what capacity means. As a result, students can recall the formula but cannot explain or apply it. The weakness is also highlighted in PISA, where students show a poor conceptual understanding. Next, for spatial understanding, lesson will use limited container shape and size. This causes students to believe that the taller container always hold more liquid. However, PISA requires students to interpret visual and spatial information, which many struggle with. In addition, real-life application is limited to teaching and assessment. Students are rarely exposed to daily life capacity problems, so they find it difficult to apply their knowledge in real situation, which is a key focus on PISA. Research finding and articles such as core knowledge mathematics and study on PISA performance show that a lack of spatial variation and low-level assessment tasks contribute to this issue. Therefore, teaching should include hands-on activity using different container, and assessment should involve real-life measurement tasks to improve student understanding of liter and millimeter.
Now let's shift our focus to teaching issue of measurements identified across three major international assessments, TIMSS, PISA, and CPLM, which is the lack of spatial variation. In classroom practices, this issue highlights how the way we teach measurements often fails to build the true spatial reasoning. According to Team's data, while teaching focuses on unit conversion and stated tools, there is a limited use of varied container shapes or partial fillings. Because students only practice with routine, structured problems, they perform well on procedural tasks but show very weak actual spatial understanding. For the PISA research indicates that our teaching remains too exam-oriented with very few real-world measurement activities. This leads to insufficient opportunities for estimation. Consequently, when students are faced with open-ended or real-world, real-life problem solving, they struggle to apply the measurement concepts outside of a familiar textbook context. And finally, looking at the CPRM, we see that primarily level teaching relies too heavily on ideal representations and perfectly labeled skill. Students lack of the hands-on experience needed to bridge values between markings. This makes it difficult for them to interpret the skills and measurement tools accurately in the practical assessment.
Good morning, everyone. I'm Christine. Today, I'll be presenting on assessment issue based on Team PISA and CPLM, focusing on broad understanding of milliliter and liter in primary mathematics. Measurement, especially capacity, is an important topic in the primary mathematics syllabus. Students are expected to understand units such as milliliter and liter, compare quantity, and apply this knowledge in daily life. However, international and regional assessments show that many students struggle with this concept. First, let us look at teams. From the assessment perspective, teams emphasize accuracy and correctness in measurement. More assessment tasks are structured questions with clear numerical value. Despite this, many students experience confusion about unit magnitudes, especially while when comparing milliliter and liter. For example, students may not understand that 1 liter is equal to 1000 milliliter. As a result, assessment may not fully detect student conceptual misunderstanding even though they can perform calculation. Therefore, teams highlighted the need for stronger focus on unit conversion and calculation. Next, PISA focused on reasoning and decision making in real life context. Assessment tasks are usually context-based and open-ended. However, students often face difficulty identify which quantity is more or less when different units are involved. This weak understanding of unit affect their ability to solve real-life problems, such as comparing drinks volume or household container. Hence, PISA emphasizes estimation, comparison, and justification in assessment tasks. Lastly, CPLM assess student understanding through scale reading and truth-based pattern. These tasks require students to interpret measurement tools such as measuring jar or container. Findings show that students often misunderstand milliliter and scale interpret. However, this assessment clearly reveals student weakness in unit understanding. Therefore, CPLM highlights the importance of interpreting value between marking or measurement scale. In conclusion, findings from teams PISA and CPLM show that poor understanding of milliliter and liter is a significant assessment issue in primary mathematics. Thank you.
This is our reference. Thank you.